So now we are adding I and j together. So our y of s now, don't forget we said y of s is I plus j. So which is y of s. So I'm going to add this. So this I and j is already in partial fraction. So the last step we're going to be doing is to take the inverse Laplace. So we're going to be taking the inverse Laplace of this y of s. So inverse Laplace so inverse Laplace of y of s, inverse Laplace of I plus inverse Laplace of j. So now inverse Laplace of I. What is inverse Laplace of I now? The I we did we split into partial fractions. So let's find the inverse Laplace. So that will be inverse Laplace of 1 over 36 s plus inverse Laplace 1 over 72 s minus 6 plus 7. Our c is minus 37 over 72. So we have inverse Laplace 72 s plus 6. So this will give us, so inverse Laplace, 1 over 36 is a constant, bring it out of the inverse Laplace. So I left it taking the inverse Laplace of 1 over s, inverse Laplace of 1 over s, as we all know, is 1. So 1 times that 1 over 36 is going to be 1 over 36. So now 1 over 7 over 72 is a constant, bring it out. So now we're left with 1 over s minus 6. 1 over s minus 6 is this s minus 6 is an exponential. So when you take Laplace of e exponential at, so you have 1 over s minus a. So now taking the inverse of this will be exponential 60. Then for this as well, this is a constant 72. So for this now, see this is similar to this, or this one is having plus, the one we did last add minus. So what we're going to do is apply minus here. So this is the inverse Laplace of I. So then inverse Laplace of g, inverse Laplace of g now. So g minus 12 over 35 s minus 1 plus inverse Laplace 1 over 5 s minus 6. This is 5. This is s, this is 5. So then the last one of g now is inverse Laplace of 1 over 7 s plus 6. So now this will give us, taking this constant out, minus 12 over 35. Then inverse Laplace of 1 over s minus 1. So that will give us exponential 1t. So I'm going to write it as exponential t. So for this as well, take the 1 over 5 out. Is a constant. I'm writing 5 to differentiate it from s. So now 1 over s minus 6, like what we did here, so which is exponential 60. Then this as well, inverse 7, which is exponential minus 60. So this, because this is 1, let me write it as this. So that is it now. Then don't forget, we have gotten the inverse Laplace of j and then of I. As you can see, we have returned back to function of time as it was when given the first and second equation. So now we are left with taking the inverse Laplace of y of s. And don't forget this yes, inverse Laplace of y of s is what? Y of t, the y that we're given the question. So now let's write it as it were here. So y of t is equals to inverse of I. Where is our I? This is our final inverse of I. So 1 over 36 plus 1 over 7 exponential 60 over 72 minus 37 exponential minus 60 over 72. That's what I, plus inverse of j. Inverse of j now. So add this, so we have minus 12e 60 over 35 plus 1 over 5. Let me write it as e 60 then plus e minus 60 over 7. So now let's collect like times and add everything up, and that will give us our final answer for y of t. So now adding this up and collecting like times, we have 1 over 36 minus 12 et is not 6 ordinary t, please, minus 12 t over 35 plus, we have exponential 60 here, exponential 60 here. So when we add the coefficient 107 over 72 plus 1 over 5, so we are going to have 607 exponential 60 all over 360. Then for exponential minus 60, we have minus 57 over 72, then plus 1 over 7. So when we add this up, we're going to have minus 187 exponential minus 60 all over 504. So now this right here, this is the final answer to our y of t. So we have just gotten one part. This is for y of t. Don't forget, as we know in our linear simultaneous equation, we need to find to get a and b to conclude our solution. So now we have gotten one part, we have gotten y of t. Next, we need to get x of t. So now we'll be solving for x of t next. So now, so from equation 1, that is x of s minus 3 y of s is equal to 1 plus 1 over s minus 1. So now I need to make x solid of the formula. I need to isolate x. So when we do that, when we isolate x, we have 1 plus 1 over s minus 1 plus 3 y of s all over s. So this is what, yeah, we can split it here. Now to split, let me adjust this very well. So x now x of s, when you split that, we are left with 1 over s plus 1 over s minus 1 plus 3 over s y of s. So we are left with this now. So we need to use similar approach we use during y of s. So now to do this, let's take inverse Laplace. Then we'll come back to this y of s and simplify and manipulate our way. So we can take the inverse Laplace of this simple function. So now taking the inverse Laplace of x of s equals to 1 over s inverse Laplace of s minus 1 plus inverse Laplace of 3 over s y of s. So now we know that inverse Laplace of x of s is x of t. Then for this now, inverse Laplace of 1 over s, we know it is 1. Then what, so why a little bit of manipulation, inverse Laplace of s minus 1, s into bracket s minus 1. How we just need to do is split this into partial fraction, which you end up having, let me split this, we have, put this in bracket, 1 over s minus 1 minus 1 over s. So take the inverse Laplace by applying singularity here. So we have this, we have 1 over s. So now when you take the inverse Laplace of that, we have inverse Laplace of 1 over s minus 1 will be what? And take the inverse Laplace of series will give us exponential t. Then take this 1 over s is 1. So 1. So let's add it. We can't take the inverse Laplace of this straightforward as it is because we have y of s. We need to insert our value of y of s during our first operation. We need to insert it. So let's just come back to this junction here where this place where we take our inverse Laplace, then insert it. So inverse Laplace of x of s, we say this is x of t. X of t is equal to inverse Laplace of 1 over s, 1. Inverse Laplace of this of 1 over s minus 1 is what? As plus dt minus 1, then plus this. Now this we can bring the 3 outside. So this is a constant. You cannot bring the s outside. So 1 over s over s. So this cancel this. So I'm left with x over t is equals to exponential t plus 3 inverse. I'm write this as s. So you won't think s will cancel s here. So now we have this. So we're left with taking the inverse Laplace of 1 over s times y of s. So now let's do that. Let's focus on that. So from the first part we did, where we had our y of s, you remember that we split the y of s into I and j. We split it into partial fraction. So let's just insert. So we cannot use that partial fraction direct because of this 1 over s here, but we can use that split function, that is the I and j. What we're going to do is multiply this 1 over s with the I and j. So we are good to go. So now let's take this. You can see 1 over s y over s. I'm not taking the inverse Laplace yet. I'm trying to simplify this. So this will give us 1 over s y s plus 12s minus 1 s minus 6 s plus 6 plus our g now 12 s minus 1 s minus 6 s plus 6. So now multiplying it, we have this becomes s squared s minus 6 s plus 6 then plus this becomes s minus 1 s minus 6 x plus 6. So now this right here is our 1 over s times y of s. So we just do is take the inverse Laplace of this. But as we can see, this taking the inverse Laplace of this direct will look complex. So let's split this into partial fraction once again, as we did to the first one. So we're taking this into partial fractions, splitting these two as well. So now let's name these fractions as well. So now let me call this k, then let me call this fraction m. So now let's first deal with this fraction k first. S plus 12s minus 1 over s squared s minus 6 s plus 6. Taking this, we have a over s b over s squared plus c over x minus 6 plus d over s plus 6. So the same approach, this now we have s squared plus 12s minus 1 is equals to a s squared s minus 6 s plus 6 plus b s minus 6 x plus 6. We have c s squared. Just we have we don't need s, we don't need this singular s here. So we have s plus 6. We don't need this singular x. So, and this, we only need just one of these. We only need just one of these s. And we don't need this singular s. Then for d plus d now, singular s, then s minus 6. So that is that. So now the same thing, you are going to be let s equals 6. So when you get s equals 6, this will be a will be eliminated, b will be eliminated, d will be eliminated, so we'll be left with just c. So now this part will give us 107. Part giving us 107. So this part gives us 107 is equals to, and then our c now, 6 plus 6, that's 12, then 36. 36 times 6, so we have 432. 432c. So c will give us 17 over 432. So for for the next one, let s equals minus 6. So now this part will always remain the same as the first one we did, because this part is unchanged. So we have minus 37 here. Then we have minus 432d, because it's only the d. Every other one will be eliminated because it's minus 6. So minus 6, 0, 0, 0. Only this will remain. So now, so for d now, d gives us 37 over 432. So now we are going to get, we are left with a and b. We have gotten c and d, so a and b next.